The story of our universe is not just a tale of stars and galaxies, it's a story about us, humanity. It's a journey that spans billions of years, from an unimaginable point of beginning to the current moment where we find ourselves looking back in awe and wonder. Humanity has always gazed at the stars and wondered. These words from Brian Cox remind us that in studying the stars, we are exploring our own story. Science has taken us from myths and legends to powerful telescopes that peer into the very beginnings of time. And now, with the advent of quantum physics and the incredible capabilities of telescopes like the James Webb Space Telescope, we're closer than ever to understanding how we came to be. The Big Bang Theory is often taught in schools as the ultimate beginning of everything, a single point of origin that exploded, creating the universe we inhabit today. But what did it really mean? Can we imagine a time when there was no time, no space, no galaxies, or stars? What was this Big Bang, and why did it happen? To understand this, we must dive into the nature of existence itself. The Big Bang was more than an explosion, it was the emergence of everything. Time, space, matter, and energy all came into existence in a fraction of a second. Picture a balloon inflating. It starts as a tiny point, but within seconds it expands into something larger, something visible. The universe did the same. However, some scientists like Brian Cox believe that even this explanation is limited. He proposes that before the Big Bang, there was a kind of potential, a potential so vast and unimaginable that it's difficult for us, with our human perspective, to grasp. In this sense, the Big Bang might not have been the beginning of everything, but simply the beginning of everything we know. So, what was this pre-Big Bang potential, and how can we even begin to understand it? Science is still trying to answer this question, and each answer seems to raise even more questions. Light is more than what we see with our eyes, it's the very fabric of our understanding of the cosmos. In fact, without light, we'd know almost nothing about the universe. This is because light acts as a messenger, carrying information across the cosmos and bringing it to us, billions of years after it was first emitted. In simpler terms, when we look up at the stars, we're looking back in time. Some of the light we see today from distant stars has traveled for billions of years to reach us. This means that we're not seeing stars as they are now, we're seeing them as they were long before humans even existed. Albert Einstein first described light as both a wave and a particle, a dual nature that still mystifies scientists today. Light is the reason we can see galaxies, stars, and planets, but it's also a mystery in itself. How can something be both a wave and a particle at the same time? This paradox is one of the many puzzles that quantum physics is trying to unravel. The James Webb Space Telescope has revolutionized our understanding of light by allowing us to see deeper into the universe than ever before. With it, we're able to view galaxies and stars that existed just a few 100 million years after the Big Bang, a time so distant that it's hard to even comprehend. In the early universe, there was a period known as the Dark Age. Scientists believed this time was truly dark, a cosmic void devoid of stars and galaxies, where only invisible particles floated around in a chaotic cloud. For hundreds of thousands of years after the Big Bang, the universe was too hot and dense for light to travel, making it impossible for us to see anything from that time. But the James Webb Space Telescope has flipped this assumption on its head. As it peered into a period nearly 13.6 billion years ago, it found light, galaxies, stars, and formations that shouldn't exist according to our previous understanding. The discovery that light existed during this so-called Dark Age raises fundamental questions about the nature of the universe. Did light somehow exist earlier than we thought? If so, how? And what does this mean for our understanding of the Big Bang itself? This discovery has caused scientists to reconsider our cosmological models, making us question what we really know about the origins of light and matter. It's as if the universe has been hiding secrets in plain sight, waiting for us to develop the technology to see them. To fully grasp the universe, we must dive into the baffling world of quantum mechanics. Quantum mechanics is the study of the smallest particles in the universe, particles so tiny that they don't even behave in ways we consider normal. Richard Feynman, a renowned physicist, this is because particles at the quantum level behave in ways that defy all logic and intuition. They can be in two places at once, change states depending on whether they're observed, and even communicate instantaneously across vast distances. This bizarre behavior is part of what scientists call the quantum fluctuation, a field where particles pop in and out of existence. It's believed that this fluctuation might have existed before the Big Bang, a kind of quantum sea filled with endless possibilities. Our universe, then, could be just one of these possibilities that managed to stick, giving rise to the cosmos we live in today. But what if there are other possibilities, other universes that didn't collapse into nothingness? This idea, known as the multiverse theory, suggests that countless other universes might exist alongside our own, each with different physical laws, different forms of matter, and even different versions of reality. If our universe came into existence due to a quantum fluctuation, then it's possible that other fluctuations gave rise to different universes. This notion is both thrilling and unsettling. Imagine a universe where everything is pink, where matter flows like a liquid, or where time runs backward. These ideas may sound like science fiction, but they are entirely possible within the framework of the multiverse theory. Some scientists believe there could be an infinite number of these universes, each with its own version of physics, matter, and reality. In one universe, stars might look completely different. In another, life as we know it may not be possible. And in yet another, there might be beings contemplating the same questions we are, wondering if there are other universes like theirs. Throughout history, people have looked to religious texts to answer questions about existence. For example, the Bible says, "This mirrors, in some ways, what science has come to understand about the origin of the universe." The Bible's statement about light echoes the scientific discovery that light is at the heart of our understanding of the cosmos. Science and religion, though often seen as opposites, both strive to answer the same fundamental questions. These parallels give us a unique way to think about our place in the universe. While science offers concrete data and testable hypotheses, spirituality provides meaning and context to our existence. As humanity pushes forward with telescopes, quantum experiments, and philosophical debates, we are continually drawn closer to the heart of cosmic mysteries. What began with basic observations of the night sky has now led us to the very edge of the universe, and with each discovery, we realize how little we truly know. The journey to understand the universe is far from over. As long as there are stars in the sky and questions in our minds, humanity will continue to explore. The story of the universe is a story of discovery, mystery, and endless curiosity, a reminder that even as we learn more, the cosmos holds infinite secrets